Okay, let's continue on the second section. Okay, so the first is the 6.51. So that's the acceleration caused by it's the feet per second square. Then there are approximately this one per meter and the 60 seconds per minute. So, okay, this is the unit conversion. Okay, let's see how we can do it. So 32.2, right? 32.2, right? And this is the feet per second square, right? Equal to 32.2, right? Over feet, right? The 1 feet is, we change to meter, right? And the second square, right? We change to the minute square, right? Okay, so then this one equals 32.2 times 3600 over 3.28 per meter per minute square is equal to 35340 meters per square is somewhere 35300, right? You to the nearest 100. So meter per minute square. Okay, next. So 6.52, right? So okay, so it's the at the beginning, set her watch to the correct time at the noon, right? So there are 2 times. One time is called the true, the other is called the read. Okay, so at 12 o'clock at noon, they both the same, right? Then at 1 p.m., she noticed that the watch will read at the 12:57:36. Okay, so the question is asking you if here is 10 p.m. What is X? Okay, so basically because you can see the clock is running slow, right? So this time must be greater than the 10 p.m. And we need to figure out the ratio, right? We need to see how slow it is. Okay, now let's figure out the ratio. So from the true is 1 hour. What is the read? Okay, so the read is 2 minutes and 24 seconds. Okay, from the 1 hour, right? This one is equal to the 2 minutes plus the 24 over 60 is 12 over 5 minutes. Okay, and equal to the 12 over 5 over 60 is equal to the 1 over 25 hours. Okay, so you run 1 hour, you lose 1 over 25 hours. Means for the true 1 hour, the real clock only runs this percent of the hours. Okay, so that means if we run the X hours here, right? We run X hours from 12. So X hour times the 24 over the 25, right? Equals to the slower we run in 10 hours. So then we can calculate X equals to the 10 times the 25 over the 24 So it is equals the 10 plus the 10 over the 24. This is the hour, right? So equals to the 10 o'clock. And let's convert in this one to minutes. 10 over 24 times the 60, right, is equal to the 10 to the 25. So this is the real time. This is the true time. Next. Okay. The ABC are the winners of the school drawing of piles, and if they are divided in a ratio of the 3 to the 2 to the 1, right? Due to some confusions, they come different in time. Okay, so we need to understand what happens with this problem. At the beginning, it takes me out about 1 minute to figure out what's going on here, okay? So what does the confusion means, okay? So, and they come in different time, okay? So if they come in the same time, right? Let's cutting it. 3 piece, 2 piece, and 1 piece. Okay, I'm sorry, it's not a very good ratio. Okay, 3, 2, 1. So if they come in the same time, right, they know one take this amount of piece, the other take this one and this one, right? What does it mean? I mean, they come in different time and both assume they are first to come. Okay, for example, the first come, the A comes, he think he need to take the three piece, right? That, I'm sorry, that's half of it. So he takes the 3 piece, okay. And but when the B comes here, he think this is the total. This is the total, okay, and he cannot take the 2 piece of this, right? Yeah, he can only think this is the total. He can only take the 2 piece of the half. So he only take the half of it to dash. Okay, so that's why there is some remaining, because when the new people come, he think the rest of the piece is the total what they have. Okay. So now let's take a look at what's going on. Okay, so here I want to use alpha over beta over gamma to show you what's going on. Okay, this is the general ratio. Let's see. When A comes here, right? Here is the take and is the rest. When A comes here, he takes the alpha of the whole, right? And you have 1 minus alpha left, right? When B comes here, he assumes 1 minus alpha is the whole, right? So he takes the beta of the rest. And so the rest of them will be the 1 of the beta and the minus 1 of the rest. When the C comes here, right, he takes this is the whole. So it's the gamma times 1 minus beta and the 1 minus alpha. So the rest will be 1 minus gamma, 1 minus beta, 1 minus alpha. Okay, so from here you can see I can, based on when they come here by the order, right, I can alpha, beta, gamma can be a permutation of the 3 piece, 3, 2, 1, right? And the final answer doesn't change, because no matter what it is, it's a permutation of that, right? Divided by 6 is the total piece. So they should be a fractional number. So now you can have what's the final. The rest of the piece is equal to the 1 minus alpha, 1 minus beta, 1 minus gamma is equal to 3 over 6 times the 4 over 6 times 5 over 6. Okay, So this is how you get it. Is equal to 5/18. Next. Okay. So Dick and Nick share the food with Albert. And Dick has the 5 loaves. And Nick have 3 loaves. And this one has 0 right at the beginning. And but after they share, right, they have shared equally, means total is 8 pieces, right? So 3 8, 3 8, 3 8. Okay. Now let's see what is how many pieces that D contribute, right? D gives the 7/3 piece, and N is giving the 1/3 piece, right? And the Albert have $8, right? Albert contributed the $8 to both D and N in proper ratio, right? So together is $8, right? So you can see it's 7-1. We need to split the $8 to 7-1, so you know it's $7 here and $1 here. Okay, that's it. Next, okay. So this is a geometry problem. Okay, it's not that really hard. You really need to understand some basic ones. Okay, so you really need to know, and the clock side we have the 12 hours is corresponding to 360 degrees. So you know 1 hour will be 30 degrees. And you know the 60 minutes is 360 degrees. So that means 1 minute is 6 degrees. Okay, this is what you need to know. So here is 12, right? Here is 10, and somewhere is in the middle is 11. So here we have the 30 degrees. Okay, let me use another color to draw something for you to differentiate it. Okay, so let's use the red one, okay, to represent the current time. Okay, so this red one is current time or now. Okay, let's use the blue one to represent they should be very close. Okay, 3 minutes. But in order to let you see it, I just draw it. Okay, this is the 3 minutes ago. Okay, so let's see if this is the X. Okay, this is the X. Sorry. This is the Y is the hour. This is the Y is the hour. Okay, so this is the Y minus the 3 minutes. Okay, now let me switch to black. Okay, so 3 minutes is corresponding to how many for our handle, right? For our handle is 3 minutes over the 60 minutes times 60 minutes is 30 degrees, right? So it's 3/2 degrees. Okay, and let's assume here is the X degree. Okay, now we can generate a corresponding between the X and the Y, right? So if it is X degree, right? And we have the Y is the how many, what is the hour against the 12, right? How many hours against the 12? So we can do we can see how many hours against 12. This is the hour, right? So now let's do it. So x degree is x over the 30 in the hours to 12. Okay, then the 3 minutes ago, right? I mean 3 minutes ago, right? 3 minutes ago it is y minus 3 minutes ago. Okay. 3 minutes ago it is the x degree minus the 3 over 2. I'm sorry, plus. Right? This is the 3 over 2 degrees. Okay. Now we need to calculate, okay, at that time, what is the minute handle, right? Oh, hold on. Okay, and we also have a minute handle here. Okay, so the minute handle, think about it, okay? So the time is 10 point something, is 12 minus the y. This is the time, right? This is the current time, right? And this time minus the 10 o'clock is the sub hour, right? It's less than 1 hour, right? So this one is the minutes, right? So let's calculating for this minutes. What's the minutes handle? What's the angle of the minutes handle of z, right? So let's calculating the angle z will equal to the 60 is converting the hour to minutes times the 6. Okay. This is the degree of now for minute handle, right? Okay, now we have this, and we know the 6 minutes later, right? It will it will on the opposite side of the of this blue line, right? Let's do it. So 6 minutes later, that means the z plus 36, right, equals, I mean, then it's a supplementary, right? So plus x degree plus the 2/3, right? They get it is equal to the 180 degrees. Now let's solve equation, okay? So we have the 2 minus x over 30 times the 360 plus the 36 plus the x plus 3 over 2 is equal to 180. Then we have the 11x equals 576 plus the 3 over 2 is equal to 21155. Then we can solve the x in degree, right? Is equal to 105 divided by 2 is equal to the 52.5 degrees. Okay, if you know the x is 52 of this 0.5 degrees, right? So basically you can solve the y is equal to 52.5 over 30, right? it's the 1.75 hours, right? Now let's count now the time, the current time, right? So the now time, right, equals to 12 minus the 1.75 hours, right? So it's 11 o'clock. Then 3/4 hours is 11 o'clock minus the 45 minutes is equal to 11 is equal to 10:15. Okay, yeah, so this is the problem, is you have to be very familiar with how we cutting the angle. What's the relationship between the angle and the hours and the time? Okay, so that's it. Thank you.